For safety, wear chemical splash goggles and a chemical-resistant apron. Nitric acid is very corrosive to all body tissue and toxic by ingestion and inhalation. In the lab area, wear closed-toed shoes, not sandals. Remember to always keep nitric acid in the fume hood. Brass is an alloy of various metals, including copper, zinc, aluminum, and tin. Copper, zinc, and iron are typically the most abundant. The amount of copper in a given sample of brass affects properties such as color, hardness, ductility, and conductivity. Spectroscopy can be used to determine the percentage of copper in a sample of brass. Because the absorption of electromagnetic radiation causes different kinds of transitions within the substance, the energies of these transitions are characteristic of a specific atom or molecule. The concentration of a color transition metal ion solution can also be determined by measuring the color intensity. Absorbance is proportional to concentration according to Beer's law, A equals A, B, C. The purpose of the introductory activity is to compare and distinguish the visible spectra for metal solutions containing copper, iron, and zinc, the most abundant metals in brass. To begin the intro activity, turn on the spectrometer. Allow it 15 minutes to warm up. Each group will be assigned a metal solution to analyze. Fill a test tube with the metal solution. Fill another tube with deionized water and put a piece of chalk in the other. On the spectrometer, set the wavelength to 400. Wipe the test tube with deionized water inside and place it into the spectrometer. There should be 100% transmittance. Repeat with the chalk test tube. There should be 0 transmittance. Do this for each of the metal solutions. Record data at different wavelengths. Repeat every 20 nanometers from 400 to 700 nanometers. Remember to use ChemWipes. The data can be used to create a table and graph a calibration curve in Excel. Using your graph of each solution's absorbance versus wavelength, you will be able to determine an acceptable wavelength that the copper solution absorbs. You will also graph a calibration curve for copper that shows absorbance versus concentration. Absorbance is directly proportional to concentration according to Beer's law, so your calibration curve should be a straight line. The purpose of the lab is to use this data from the introductory activity to determine the percent of copper in a sample of brass. The absorbance of a solution containing the brass must be analyzed to determine its percentage of copper. Lab setup. You will need a 50 milliliter beaker. Nitric acid. Keep the nitric acid in the fume hood. It is very dangerous. Brass beads. To find the mass of the brass, take the weight boat and zero out the balance. Then measure and record the mass of 2 to 3 brass pieces. Place the brass in the beaker. Have your instructor measure out 5 to 6 milliliters of nitric acid in the fume hood. Pour the nitric acid into the beaker. The reddish-brown gas being produced is nitrogen dioxide, and it is toxic. Place a hot plate in the fume hood and turn it on to a low setting, 1 to 2. Place the beaker on the hot plate until the brass is completely dissolved, 15 minutes. Measure out 30 milliliters of deionized water in a graduated cylinder. Add the water to the brass solution. Use a stirring rod. Put the brass solution into a test tube and record the absorbance in the spectrometer. Use the ideal wavelength you determine. After measuring the absorbance of the brass, compare the absorbance to concentration on your copper calibration curve graph. Use this concentration to calculate grams of copper out of the mass of your brass sample. Multiply by 100 to get the percentage.